Okay, today we are going to see the unit 4 of artificial intelligence. So unit 4 of the topic is machine learning. Okay, so the machine learning, coming to the part of the introduction, a ML algorithm overview types, and then introduction of neural network. So how they are going to work in the deep learning, and what are the applications of DL, and ethical consideration of AI and ML. So these are the introduction part of the machine learning. We will see the brief explanation about the unit 4. The introduction of ML algorithm. ML is nothing but machine learning. So the AI subset of the machine learning function. So involve building algorithm that allow computer to identify pattern in data and making prediction or decision without being expertly programmed for each task. So this algorithm can be broadly categorized based on how they learn from the data. Okay, how they are going to learn from the data, expect program to the each task to performing the building algorithm to allow the computer to identify the patterns and data process. Okay, so you're going to find the making decision prediction from functions also, and then these are the algorithms is a broadly to based on the how to learn the data. Okay, so what are the types of the machine learning algorithms? Are they supervised learning, unsupervised learning, and reinforcement learning? Supervised learning is nothing but algorithm is trained the labeled data, meaning the output label. Okay, so for each input is already know the goal is to learn from mapping from input to output and making prediction and new and see data. For example, I will tell the supervised learning. You can take one cat picture and dog picture. Okay, so the cat picture, dog picture, you as a human being you know very well, but the machine we don't know how what is this a cat or dog. We don't know the name and all, but you can criticize. You can recognize that the picture as a feature. Okay, so what are the dog shapes and what are the cat shapes or picturized form of the making to the uh, function. So that is called as a patterns. Okay, so patterns and features, you can enzymes, you collect the features and you're going to put it in the model, train model. So that is a train model, that is a collecting data. You're going to train the model and you can perform in the good model of the function. Okay, so that is called as a supervised learning. Okay, so what are the examples of given the supervised learning algorithm? Linear regression, logistic regression, decision tree, random forest, and SVM, that means support vector mission, KNN algorithm. So linear regression, you can predict the predicting house price, and then logistic regression, you can predict the span detection, that means binary classification, decision making model used to classification and regression, and random forest is a tree, decision tree. You can better performance of using the random forest. SVM is nothing but optimal hyperplan, and then KNN is nothing but which is the closest near the algorithm you can find out the function. So all these comes under the supervised learning algorithm. The next one is example of the supervised learning algorithm is linear regression. So you can take one house prediction of predictive house price based on size, location and all. You can use the algorithm. You can import the algorithm is sklearn. Okay, sklearn linear model, and then you can import the panda here. Okay, so I am going to import example of the data. DF is nothing but data frame. So panda data frame of the size of the house house prediction. So 1,500 and 2,000, these are and all will comes under the square feet of the particular area. You're going to find out the size. You can take some data and you're going to sort out the function. And what is the train model here means linear regression. I'm going to find out. So what is the model fit here? X axis and Y axis. What is the prediction model means 1,800 square feet. I'm going to predict the overall model. Okay, so this is one of the examples of given the linear regression. So the next example of machine learning is unsupervised learning. So unsupervised learning is nothing but the algorithms given the data without expert label and must find hidden patterns or structures in the data. So they don't know dogs or cats. You can picturize that one. You can find out the features of the dog and as well as features of the cat. Okay, you can collect the data of the dog, height, nose, ears, and then tail. So all those things, these are under features of, you can take it as a pattern and then collect the data to performing in the label. So these are under will call it as a unlabeled data to using the unsupervised learning. So one of the examples of using unsupervised learning here, K means clustering, hierarchical clustering, and then TCA is nothing but principal component analysis and onboarding deductions. Okay. And unsupervised learning algorithm example, the good example they have given, the K means cluster. So K means cluster is the closest cluster you're going to find the data. Okay, whether it is closer the data to find out the prediction right or not. Okay, so you're going to import the numpy here. So they have given the value of spreading the score of the age. Okay, and then what is a cluster? They have written the two cluster, 25 500 and 30 600. So these are under the two cluster means you're going to label in the function. So hierarchical is another example they have given. Hierarchical clustering means you're going to leakage of the function. You're going to import the cluster model is a NumPy and MATLAB. So data I'm going to find out the 1 2 3 4 10 12 and 11 14. So these are under all 3D dimension function. So 3D dimension function you're going to find which is the closest to the K means algorithm and hierarchical clustering function. The third example of machine learning is reinforcement learning. You can take an example as one gaming part. Okay, so reinforcement learning is an agent learn from interacting with the environment and receiving feedback, rewards and penalties. Okay, the agent aim to maximize curriculum rewards over time. For example, they have given Q learning and then deep Q network. So reinforcement learning agent that learn to make decision to interact with the environment and maximize reward over time. So how we are going to import the function, the table of the state space action space. Okay, so state space and action space you're going to solve the reward function. So reinforcement learning you can find the four function of the function model. So that means first one we can call it as a agent, environment, action, and then policy, reward. Okay, so the starting you're going to perform one game. You can win the game and you can reward the game also, but you cannot win the game, you can fail the game means you can use one penalty. You can use a penalty to you can give the feedback of the receiving to the penalty function. So that is called it as a reinforcement learning of the machine learning.